Hey, how's it going? Tonight, we're in for something a little different tonight. We're doing Minecraft, but we're doing coding. I feel like we'll probably see more code than we see Minecraft, but we'll see how it goes. This is sort of an experimental stream to see if this is something that actually would work on Twitch or not. It's also something that I need to get done for the next Minecraft video, so why not do it with you guys, right? And another thing is I made some really, really good progress on it yesterday. I spent from about 10 a.m. to 11 p.m. with short breaks in there, like fixing stuff. So we've made some really good progress, and I have a list of things that we can work on. So we're gonna switch it over to the main scene. This is where I broke the camera. So we'll see if the camera gets fixed here. I'm there. However, I do want to leave the music going because I think it's going to be better with music. And want to make sure that we're doing display capture, not game capture. That way we can see the code. So here's going to be a question for you, Bomber, since you're here. Is the code readable or is it too small? If you're watching on a phone, it's probably way too small. I'm going to open the game, and we might get that black screen switching back and forth between game and code, but we're going to have to switch back and forth quite a bit. Yeah. So you can read it on your secondary 1080p screen. Okay, good. If I need to increase it, I can zoom it in. It's not that big of a deal. It's just it is easier to code when you can see more lines of code at the same time. This is probably going to be very difficult to actually read because it is my handwriting, but I'm going to write some of this somewhere. Actually, I don't even know if it's reversed or not, but that is my notebook, and this is where I've got like multiple pages of notes on what the program needs to do. I've got like UI mock-ups on this thing, all sorts of things that I've been noodling on to get the code to work, right? How's the music as well? I'm kind of wondering if I should tone it down just a little bit. What do you think? Especially since we're going to leave the music going, I think, the whole stream. Good, thank you. Okay, so I'm gonna run through what the current situation is on here. And this is for anyone who hasn't followed my YouTube Enigmatica 6 Expert Series. Let's do a quick rundown of what the series is and what the world is like, and then we'll get into what we're doing. So I have a spellbook, and Enigmatica 6 Expert is an expert mod pack, which means that there are lots of mods in the game, but you can't do anything you want right off the bat. You have to work up for it. Everything is gated. If we take a look, there is a quest book, and in the quest book, here are the gates, and you can see we're about halfway through with, more and more complicated or cool things the lower you go, but there are tech gates, there are magic gates, and there are things you need in tech that you get from magic and vice versa, so you're incentivized to go back and forth and do multiple things. We're currently working on some magic things. However, right, so we've gotten to tier 3 on tech. We're only in tier 2 of magic. We're almost to tier 3 on one half of this. It's gonna get night. I'm gonna sleep real quick. was just gonna say, this is funky, but it's Funkbox. Okay, and so we have ourselves a village, and I have an elytra on, so that's my wings, and with the spellbook, I have a spell called Leap, and this lets me propel myself forward, so it helps with the flying quite a bit. In the world, we have a village that we have claimed as our own, and we've done some modifications to it and things. I will show you. This is my main building. This is my hub, the main sort of operation center, although it probably won't be for long, but it is today, and this is where our inventory system is. The crafting grid from Refined Storage is here with all of our items in it. There's lots and lots of stuff in there, and this thing can do a lot. However, in this mod pack, this is the crux, this is what we're working on today. In this mod pack, Refined Storage is really, really expensive on the power. If I come down here, we can see that we're currently using 2,451 FE per tick. And our generation... You arrive in the village and say, look at me, I am the captain now. I have delivered the villagers from a world of fear and zombies and saved them within a walled fortress and gave them lots of iron golems to protect them. We have this Furnator from Powa that's supplying our power, and this thing is actually able to generate 4,000 FE per tick. So we're clearly able to keep up with this one machine on our power demands, but it very, very quickly gets out of hand when you start adding in crafters, and that's what I want to do, and we want to have like all sorts of importers and exporters so that we can hook all the machines and everything up so we can like set up automation and automated crafting and stuff via the system. It's just not feasible with our current power level, right? So that's what we're kind of working on, an alternative. And that thing was burning coal, and it burns the coal from this. This is our tree farm. This machine, when it detects it needs power, so that block looks like it's lit right now, which means we should see pretty shortly this thing go around and harvest the wood in order to turn the wood into charcoal to burn in the Furnator. I'm going to turn the music down just a tad. Just a tad. Okay, just a tad. I felt like that one was overpowering me a little bit. Again, black screen. That's going to be unfortunate. I feel like with display capture, we shouldn't get that. It should be an instantaneous sort of thing. But anyways, this is what we want to replace. And I don't know that I want to replace it exactly for, like, my inventory, because this is really handy. I mean, it's built in, like, they did a lot of good work on this, so I can search and say, like, oh, I want, I don't know, apples. Do I have apples in my system? I can just type it, and I can find I do have apples. I even have something in here that, oh, that's for... I don't know why. I don't know why that came up. APP is what I typed. Something in there has APP in it. Doesn't really matter. Oh, scrapping. That's where the APP came from. We could absolutely sort of re-implement this system, but I don't think I want to re-implement this. What we want to re-implement is the crafting portion, and so I can do display craftables. And so in this system, I already have some things set up for crafting, so if I wanted to make bricks, I could tell it, you know, we want 10, and then I could say, oh, look, it knows that we have 40 available bricks, we're good to go, start the craft, and it's going to make the bricks, even though I didn't really need them. But we just did it anyways. That's what we're re-implementing over here at our factory. We've got other buildings, other factory buildings around, and there's a lot of stuff to show, but that's not really the purpose of today. Unless people come in and want to see more, then we'll get to that. However, this building right here is our purpose today. This is the beginnings of our factory. And you know what, Bomber? Your one comment. So I had posted, how should we do this factory? And the thought that I had in mind was every new craft we want to do, we'll build a new room, and we'll add a room onto this building, and eventually it'll be this massive collection and hodgepodge of rooms and stuff, and maybe different floors and who knows what. But I got to thinking that it might be nice to have a lot of stuff out on a big open floor, like you had suggested, so that we could, like, walk on scaffolding or catwalk or whatever above and see different things running. If they're all in their own separate rooms, we won't be able to do that. All we'll be able to do is we'll be able to walk down a hallway, turn into a room, and then see what's going on in that room. And that means 2 rooms over, you won't really know what's happening over there unless you were to walk out and go take a look at it. Whereas if this was one big sort of open floor plan, we would be able to see stuff working. So that's kind of what I'm feeling like. Maybe we'll leave this how it is, but maybe the next thing we'll do will be in a much larger sort of scale, and we'll try to put multiple crafts in it. And maybe we'll have different rooms of factory like that. I haven't fully decided. But the code, that is what we're here for today. But let me give a brief overview of what I want the code to do. I want it to become our crafter. So I want to be able to come up to this screen, which is running right now, and we'll take a look at it. But I want to say, I want to craft, and if we did the same example from before, I want to craft bricks, right? We'll have to program in how to make bricks, but that's actually not too difficult. We'll have to build the machine that actually makes the bricks, and then we'll have to program how to get that whole process to work. Right, and that's what we're working on, is how to get it to work. Once it's there and it works, adding new crafts is really simple, and we don't have to change the functionality of the code. This is one area where we have all sorts of different crafts. This is one. This is one right here. This is another one right here. There's different lines. They come to these things. They come out. Here's another craft right there that goes into this. We have another craft down there, and we have one here. That's the final one. Right, so we have a whole bunch of different crafts. I think there's 7 in this room in total. And this is what we're going to be replicating anytime we want to make a new craft. The code. Let's get to the program, the computer. Here is our current version of the computer. And I know that our current version of the computer could be better, right? In many different ways, and it's not even finished yet. So once we get it finished and working, then we'll be free to do improvements to it. But we need to get to that stage first, right? We need to have what's known in like the software engineering field an MVP, which is your minimum viable product. It doesn't need to be the best. It doesn't need to have all the features. It just needs to do the one thing it's supposed to do. Or, you know, the many things it needs to do in order to make a cohesive package. And that is what we're still working on. But we're getting really close. So this window here has no work done on it. We might get to working on this today. I'm going to show you what we have here, and then we're going to run through my notes. I have a list of, I think it's 10 big things that need to be worked on. So we hit the crafting button, and these are crafts that we have programmed in, and it knows about. I anticipate this window, you know, eventually we're going to have so many crafts, it's going to go down, and we're going to have to probably come over and then make, like, separate columns for these, and that's fine. Eventually, if we have many crafts, we may need to page it and have, like, you know, this would be page 1, and you click a button to go to page 2. We might want to alphabetize this at some point. I also have a plan in place to turn things off. So let's say we never need to manually make network cards. I can set that to be false on the visibility, and it'll, like, turn itself off. When we click on one of these crafts, this is actually quite new compared to what someone may have seen. Yeah, I'll see you when you're back, Bomber. This is quite new to what someone may have seen if you've been following along with the videos. So, used to, when I clicked craft, it used to say, all right, this wired modem, it needed like 3 things, right? Those 3 things were listed in there, and it would tell you how many you need, how many you have, and how many are required. But now, it does more. It says, oh, wait a second. This is a great example, the network card. We need 1, we have 0, so required is 1. Instead of the code saying, well, you don't have it, you're done, it says, oh, do we know how to make a network card? And if we go back, we'll see network card is one of the crafts listed here. So the code is now able to say, oh, I know how to make a network card. Let me add those subcrafts into this list. And so that's what's happening. And they might be subcrafts or they might just be materials, right? But we go through the list, we go through each item, and we keep going down and down and down until we get to the base materials. What do you need in order to make this craft? And what are things you can craft? When we look at this, if it's white and 0, it means we don't need any, you're good. If it's yellow, or orange, actually, this is actually orange. If it's orange, it will tell you, you need 1, in this instance 1, but we know how to make it. When it's red, it's going to say, we don't know how to make it, this is what you need. So in this situation, if we wanted to do one of these crafts, we would need to give 4 plastic sheets, 3 Invar nuggets, and then 3 reinforced stone slabs into the system. And by the system, I mean the inventory back here, which is all these drawers. We're still working on filling out more of them, of course, but we're going to put them all in here, and then once it has them all, it will be able to pull them out of the system and know it has them and use them. That's great. Another large, it wasn't a bug, kind of a bug, but it was more of an oversight, was this used to blink. This whole screen used to blink, and we resolved that. We might take a look at how that was resolved in the code. I don't know if we're going to get to that. I mean, we're certainly going to work on new portions. Something else that was resolved last night was if we added, let's say we want to make 64 of these, or we want to make, you know, a whole bunch, okay? So you're going to notice these are now bigger numbers, much bigger numbers, right? And if we go all the way back down to 1, what would happen is it would overwrite like the first field, but not the rest of them. But now we have the code aware of how many characters should be in each one of these columns, and it's able to clearly, or not clearly, it's able to clear itself out when it needs to update in the correct manner. Another thing that has happened by requesting so many, like we're not going to try to make this many, right? But what has happened by requesting so many is we've added more and more items in this list. You'll notice this list is longer than it used to be. And one of the other bugs was this, we went all the way back down to 1. The bottom rows wouldn't wipe themselves back out and become clear. They would just keep the old data all around. And that was all visual bug. It had nothing to do with the data tables, but it was all on the screen. Let's go ahead and take this back down to 1, and we'll see it update. Aha. So something we have right now is this screen recalculates itself every 2 seconds. We could speed that up. We could try every 1 second. We could try every half a second. I think I'm okay with it being on 2, but that does mean we have a little bit of delay between clicking a button and then something happening, right? We can also increment our crafts by like 1. And the other thing too is you don't have to click and then wait for it to update. We can say, oh yeah, we want 5. So clearly I need to click this 3 more times. 1, 2, 3. We'll see that desired go up to 5, and then everything correct itself. Great. Cool. So, what remains is my header for this section. Welcome back, Bomber. You did just miss some of what I had worked on yesterday. But that's fine. I'm sure we'll talk about it again. What remains, the header on my current note page, is a selection of, what is it, 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 bullets of what we need to work on, I think, in order to really get this in a state that I like. The first one is fix the back buttons, and I have this marked as low priority. Okay? And what it means to fix the back button, I'm going to show you right now. I hit back, and you would expect, if I hit back again, it should take me back to the original main screen, which is the monitoring window. But when I hit back again, it's actually going to take me back to where we just were, the craft detail. Because what I have is I have a buffer, and it's storing what page you were last on, and then overriding where it should go based on that, when really it should probably just be a hard-coded, if you're on this page, the one before it is where the back button takes you. So that's kind of an easy fix, but it's low priority, so we're not going to work on that right now. We have relogic the execute button to see if all the base craft items are true and present. All right, so what this means is we have this execute button here, and right now this execute button is active. It's red. It's not grayed out. And maybe graying out isn't the best way to do it, since these buttons over here are kind of gray. But that's how I have it set up right now, is it'll be red when it's ready, when you can click it, and it'll be gray when it's not. I did a lot of rework yesterday on refactoring all of the number logic out of the same function that does the display logic. And that made stuff a lot more robust, and we're good. But when I did that, I also added in all of the subcraft details, and now our execute button doesn't have any logic basically assigned to it at all. It's just there, and it's technically active, but it won't work right. Right, so we need to make it so that that button only becomes active when the base craft items are true and present. And what that means is if you see a red number in here, that means it's a base item, and it also means you don't have enough. So if any of these are red and have a value, I mean, technically they shouldn't have a value unless they're also red, then this should be grayed out and not accessible. So we need to write that logic. And then the next item is the execute button needs to initiate a new crafting sequence that will use the craft table. Yes, we are crafting some enigmas. Yep, that's exactly what we're doing. My mind is an enigma. Get the reference? I applaud you. So execute button will need to initiate a new crafting sequence that uses the crafts table. So when we populate this, we're actually doing two things. We're creating a crafts table, and that's what crafts we need to do. And we're also then creating a secondary table that is our required materials table. This is actually the required materials table. Now, that being said, a wireless transmitter is also a craft. So this wireless transmitter ends up in both tables. No. You know what? I'm not going to say that there isn't a reference in Batman. There might be. It's not the one I was making, though. I'm trying to think of the scene in Batman. Anyways. So what needs to happen when you click that execute button, right, is we need to, in this one, clicking that execute button is going to be a big chunk of code. And I don't really anticipate us getting that complete today. I don't even know if we're going to start that one. I think we might start some other ones first, but we'll see. We'll see how it turns out. But it's going to be big because it needs to do a couple things, and it needs to. It might need to have some of my sub bullets. Let's get to the sub bullets. We need to have an inventory monitor, and that's going to know how many items are present at craft time. So when you hit that execute button, it needs to recalculate the database of what items are in the system and how many there are and how many we're crafting. Because we need to know when the crafts are done. And so what does this mean? Let's pretend, let's go back, go to a much simpler craft of aluminum sheet metal. Okay. We need 4 aluminum ingots in order to make the aluminum sheet metal. We have 48, so we need 0. So this is a really simple craft, and we could craft it right out. But what do we need to know? Well, we need to know when it has finished. So when we go to make the aluminum sheet metal, the craft needs to know how many are going to be produced, all right? And it also needs to know how many we have at the start. So it's not present on this screen how many aluminum sheet metals we have, but if we just come back in here real quick, we can take a look. We have 82 aluminum sheet metal. Okay, so when we go to make the aluminum sheet metal, you actually make them in batches of 4, and we can actually take a look at this. This is the craft that we're doing over in our machine. We're taking 4 aluminum plates, and we're making 4 aluminum sheet metal. So the code knows when you craft this recipe, it makes 4, right? So what it needs to do is it needs to know, at the time of craft, we have 82. We're not done until we've incremented that by 4, right, up to 86. And then it's going to know, we must have crafted them all. They're now all in the system. We can cross that one off our list and move on. When we have a table of multiple crafts it has to do, right? It has to do the There's the big original craft, and then there's the sub-crafts below it. It needs to start first with the sub-crafts, because the sub-crafts are required for the overall higher tier craft. Higher tier craft. It has to start with the bottom one, and then not move on to the ones above it, because the ones above it may need something from the bottom one until it's completed. So we need that inventory monitor to monitor everything to understand when crafts have completed. We could get really clever with each machine somehow outputting a redstone signal to tell the computer it's done or something, but I feel like that's way overkill instead of just watching the items in the system. What that does mean, though, is if we queued up 4 aluminum sheet metal, and I went in the back room and I shoved 4 more aluminum sheet metal in the system before it was done making them, it would say, oh, we're done, move on. Which might not be a problem, honestly. Probably not a problem. What would be a problem is if I went into the storage back there and I took out aluminum sheet metal while it was crafting, because then it would say, oh, wait, we're lower than we started at. Basically, it's going to say we never got to where we needed to get to. That's just something we need to not do. The next bullet item. You were referencing Diablo 2. That's a good reference. I'll be very honest with you. So Diablo 2, I've played, right? But I've not sunk tons and tons of time into it, so I never really got to endgame in Diablo 2. However, Diablo 3, I've sunk tons and tons of time into, and I like going back to Diablo 3 for the season content every so often. I haven't played it, though, in years, but it's a game I could always go back to. I really like Diablo 3. Diablo 3 started off as a pretty bad game, though. But after, what was it, Reaper of Souls, or whatever it was called, then it became pretty good. We need, next bullet, a new crafting sequence to get item locations at craft time. Okay, so the other thing that we need to do is not only at craft time, when we hit that execute button, not only do we need to know if we have enough items in the system, we need to know where they are. So this drawer controller manages all of these drawers, and each drawer has an address, right? And we need to know the address of the item so that we're able to correctly tell this thing to give me 4 of these or whatever it is, so that we can go deposit them in the correct machine. So we need that. We actually don't need that at execute time. We need that at craft time, which is slightly different, because if you have 4 crafts in your queue, craft time is going to happen each time one of those is ready to start. We need the monitor window, which unfortunately I can't get back to unless I kill the program. This is debug text. Let's ignore that. Autocrafter. This is the monitor window. So I have, this is a high level bullet. Monitor window to show current craft. Yeah, I mean, there's a lot of work that needs to get done here. A lot of UI elements that we need to figure out, like, where does this button go? The next one is monitor window to show up your queued crafts, right? So your current one and all the queued crafts underneath it. Monitor window to disable the crafting button when the crafts are in progress, meaning if we have executed something, we don't want to let you execute another thing. Jim Carrey's Riddler, you think, but yeah, his name was Enigma, right? I would imagine he probably did say something like that. I will post the Discord the reference that I was making after the stream. It's been 10 years since you've seen that movie. I'm feeling like it's been at least 10 years since I've seen that movie too. I have seen it more than once, but it's been a very long time. Next bullet point, monitor window. This one again. There's a lot of work that needs to happen here on this screen. Monitor window to have a cancel clear button. So if we've queued something up and it's working on it and we've decided, we don't need it anymore, we better have a way, click a button, and then just cancel everything. Because otherwise we have to restart the whole code, restart the whole program. And then monitor window to calculate the craft time and alert if long running. That one's a little bit more of a nebulous sort of idea, right? And it's nebulous in the sense of calculate the craft time. Well, it should be able to get a timestamp of when it started, right? And then, you know, every minute or so, say, have we finished? And if it's gone 30 minutes without finishing, maybe it should flash something on the screen here to say, hey, I think there's a problem. Because maybe we have a bug, not in our code, but maybe we have a bug over here. Let's go over here. I already know of a bug over here, and it resides on this machine here. And if it resides here, it probably resides on all of them to some extent. The bug is if you put so many items in here to craft, right? So this is just a chest. This is our input chest. If you have so many items in that chest, and let's start with these network cards. These network cards do not stack, so this might be easier to get into than I want it to be. Dancing. To our music. Goodbye. If we get a network card to come in, and it comes in here, and it moves out here, and it goes on there, that's great. And then another network card comes out before anything else. We haven't queued up anything else for some reason. Just network cards. The next network card comes in, and it comes here, and it comes here. The next network card comes in, it comes here, and I think it stays in here. The next network card comes out, and it stays right here. And now we've backed up our system. And now all of a sudden, the sheet metal and the machine bases cannot get over here for the arm to pick them up and place them correctly. So that would clearly mean that we have a backup and we're stuck without manual intervention. So, I mean, we might want to redesign this because I already know it's probably gonna be a problem, but maybe it's not gonna be a big enough problem to worry about. I guess we'll have to make that call later. But having something on the screen to say, hey, this has been running a long time and we're not done, gives us an idea of, oh, we need to go check on something. Would I need something to happen in the crafting area to throw away the pieces it's using? So, if we got in this state, yes. If we got in this state, we would need something to somehow clear it out. And that is way beyond the scope of our minimum viable product that I talked about earlier. I don't want to think about that right now because that really overcomplicates all of the machines out here. And we might be able to solve that bug over here in a different way. So let's say we didn't get into this situation, okay? Let's say we were crafting, and this thing was crafting as normal, and we had no problems here. If we canceled it over there, and we've already sent items into this box, I think that's fine. They will continue to go in, and they'll continue to craft, and then they'll eventually come out the other end. And I think we'll be fine. I don't think we'll back systems up. It does mean that if you're at like the final craft of the whole operation, and you hit cancel, it's still going to craft it. It does mean that. But if we canceled it after, like, the first craft of, like, the very, very first thing, you know, it would finish that craft and then everything else after it would stop. So I think it's okay to go with the simpler approach in this situation. But it is a really good call-out, Bomber. I didn't think of that, honestly. Which already means I'm having a really good time with the stream. And actually, that's great. So, if you've ever heard of this, okay, programmers call it rubber ducking, right? So if you talk to someone about your code, let's say you have a problem, and you just can't figure out how to solve it. Sometimes talking to someone, even if they don't understand the problem, it's literally you could talk to the rubber duck, not a real person, right? You could talk to that rubber duck, tell them the problem, and by explaining the situation to them, you're unlocking the solution in your head. So already, like, I mean, we didn't have a problem right here that we were discussing, but you came up with another problem we might encounter, which is now going to be in my head, which is great. Each piece will go back to the place it was before. No, not exactly. If if we sent in, so this right here, this makes our aluminum sheets, right? So we first send the aluminum ingots in here. This hits the aluminum sheets, and then they come over here, and this crafts it into the aluminum sheet metal. So if we, let's just say we queued up a craft over here, you know, that one, whatever, and it needed aluminum sheet metal, and so it was crafting aluminum sheet metal. So if we sent 4 aluminum ingots in here, and then we hit the cancel button at that moment, those 4 aluminum ingots are still going to be here, and they're still going to come along, and they're still going to get processed into that aluminum sheet metal, and then they'll end up back in the system as aluminum sheet metal, which is fine. We won't start the next craft over there, though, because we've canceled it, meaning it won't start the next queued up portion of the whole sequence. I think we're ready to start looking at code. Also, I changed up the glass in here. I didn't quite like it either, and I'm happy that you also called it out, because I thought it looked a little wonky. So I'm trying this one. I think it kind of meshes. It also has like a trippy look to it, because the glass is very, very see-through. Now, Bomber, if we wanted, this gets really tricky, right? Let's talk about this real quick. If we wanted to, okay, this gets into more complexity, but we could technically have this machine and its power source, all of it, on its own separate little system that comes off of a gear switch, okay? And that gear switch, you could shut it off, meaning it's not getting any rotational power, okay? So what we could do is we could send our items in here, and this whole system could be off, meaning it's never going to pull items out. And then the next step would be turn it on and craft. If we've canceled it before it started, we could theoretically actually suck the items back out of here via our wired modem and put them back in the system. So that would be one option. However, if, let's say we sent 2, because right, they come out one at a time, and let's simulate this real quick. Do I have, yes, 1, 2, 3, 4, 5, 6, 7, 8, perfect. Let's simulate this. All 8 are in. No, actually, hold up. Don't do it. Well, okay. It's not gonna matter. They're gonna go in basically at that time. But you see how they go one at a time? So if we canceled the program now, and somehow we had a way to suck these items back out, we would have a problem with this over here. Because they're kind of locked in there until the craft is done. And these, I don't believe, have a way to extract the items back out. So I think it's in our best interest to let that craft complete. That way we don't get in some weird half state that locks up that machine later on. Yes. Yeah. Uh-oh. That's a bug. Hold on, let's see what happens with this next one. Oh, this is also fun too, because it's gonna get shot. Boing! Across, into the hopper, or the chute, and then down and around. Although, you know what? It's my magnet. See that? It's my magnet. If I take my magnet off, they have dropped through, and they should have arrived over here. Yep, I just saw it poof. It was very quick. I don't want to redesign that, but I really need to design the next set of machines better so that my magnet can't screw stuff up if we happen to be walking through. Okay. Take a look into the code. I am not. So as we just went through, like, the world and the problem and what we're working with, and explained it all, I'm not going to go through and explain all the code. I will explain the portions we're looking at and what we're changing and why we're changing it. But I will tell you that there is currently 682 lines in this one file. and going through the whole thing would take a good chunk of time. Not that it wouldn't actually be good for me. It probably would be good for me to like go through everything again, but here we are. I think what we want to do first is we're going to relogic that execute button, make it active or non-active. Space elevator of code. So here's another caveat, right? I'm not writing this the same way that I would write a professional production-worthy code. I'm not purposefully doing like bad things, right? But I'm not expecting clients and customers and whatnot to be hitting this either. So there are some shortcuts and dirty things I've done, and there will be more. The other thing too is this code is in Lua, which I'm not 100% familiar with. I mean, I'm good enough in it, right, that we're doing stuff, but we will be looking things up in Lua, and just because of that means that there are going to be quirks of language that I don't know, and we'll hit, and there'll be problems there, and that kind of stuff. Not a big deal. I feel like there's another caveat that I wanted to throw out there. Yeah, it's a little dirty code. Oh, I guess the other thing too is like, you say that the code is massive, and it's not small. It's not small. However, compared to like a large legacy code base for a company, this is nothing. and you'll see over on the side, above my head here, there's like computer on the top. It says 0 and then 1, 2, 3, 4. Those are actually very different computers in our system, and we're actually working in computer number 16. That's just the ID of the computer. So everything above 16 isn't really part of this. We're only looking at the bottom stuff. And we can take a look. So aluminum sheet metal, right? Aluminum sheet metal is one of our crafts. This is what it looks like. It's 55 lines. In fact, like, this is just comment. All of these like green lines are comments. They don't actually run code. It's just for us to read. You can see this is actually nothing. I can probably delete most of that. So writing code to do a new craft, once we have the crafting system in place, writing code to add a craft to the system, easy, quick and easy. And all it needs to know is it needs to know the input chest. It doesn't even know the output chest. This is one of the first things I did when I thought we were going to use output chests. So I should probably come back here and refactor this code to make it better. But it just needs to know where it needs to put items into. It needs to know what items it needs to make the craft. And how many it's going to need. We need to have how many it's going to craft. And then the craft itself, which is the function that it calls. And you give it the drawer controller. And then you give it the items table. So, pretty simple. Back to our crafter code. I wonder, come over here. That didn't do what I wanted it to. I do this. And we're just going to put in a bullet point of logic up the execute button. This is what we're currently doing. And there. I made stuff just a tiny bit bigger. Hopefully that helps everyone. So what we need to do, we need to find where the code is for the execute button. It actually happens to be this right here. This is how it used to work. If execute ready, this was a Boolean, meaning true or false. If execute ready was true, then we would make the execute button appear as needed and have properties. And we would actually make the color red. We need to do something like this again, but instead of is execute ready, we need to calculate what execute ready means. And that means we need to go through the entire items table. So that's what we're going to do right now. And I think what we're going to do is we're going to write a new function. So this is a very, very long function. And it's all around displaying stuff on the screen. The best thing you can do when coding, right, is to have small functions that do little bits of code, and then you call those functions. the best like practice, right, is to have a small function. It does one thing and one thing only, and it does it well, and then you can call it from somewhere else to do something. We could probably extrapolate some of this code into smaller functions, and that's kind of what I was saying, where it's not exactly what I would consider top-notch code for a production code base, because I've taken some shortcuts like this function, the big one. But we're going to call this is execute ready, and it's going to calculate whether or not something is execute ready. And we need to pass in our current items table. That might be it. Yeah, I think that's it. We just need to pass in our current items table. We're going to loop through every single item in that table. And in order to loop in Lua, and we're going to loop line by line, for, okay, and we're going to do I, comma, V in pairs of the items table. Do, and then we end our loop. Okay, so this is the position in the table we are. Tables in Lua is weird. Lua starts array. A table is an array. In coding, you always start with 0. In Lua, you start with 1. So anyways, the first item is item 1, and this is the value. So what we need to do is we need to look at that and determine if it's a base craft. So if b.basecraft, and actually this is knowledge I know, right? Because I wrote the code. let me come down to actually up. Full mats table. The full mats table is our required items table. So it's our items table that we're going to be working with. We've crafted this table up here in this bit of code, and things that are in there. Hold on. Where do we do the base insert? The base insert is like right here. We're adding the tag name. So this, let's go back to Minecraft real quick. The tag name is interesting. You'll see this on here. Like my sleeping bag, the tag is comforts, sleeping _bag _white. The display name is white sleeping bag, right? So there are different things on each item in the game that are interactable. And so that's what this tag name is. And we're going to use tag names as the base identifier for items. Then we have display name, which is the easy to read name that we use for displaying on screens. We have a current amount, we have a need amount, we have a required amount, and we have that base craft. This is what we care about. Base craft true. Okay. So if b.basecraft, and this is a truthy function, meaning if basecraft was false, this would return false, and we wouldn't go into the if statement. And I'm probably glossing over lots of basic coding stuff. So if you do have questions, feel free to stop me, and we'll explain things a little bit more. But what we're going to do here is if b.basecraft, so if it's true, if the item in that table is one of the base required items, meaning not one of the middle steps that we're going to be able to craft, then we have to check if let's go back up to our table. We need to check if we have enough of them. Specifically, we need to calculate looking at the wrong table. We're looking at crafts table. Mats table. Required amount. Copy that. We need to know if required amount v.required amount is greater than 0. Then return false. We are not execute ready. That's going to end the program right there. If we hit the very first, let's say we have a list of 10 items, and the very first one in that list is a base craft, and we do not have enough, We don't need to look at the rest of the items. We already know we don't have everything we need. Stop the code. If we have made it through that entire list of code, or sorry, list of required materials, if we made it through the whole list, and we didn't hit this statement, return true. Meaning, yes, we are execute ready. We have everything we need. Let's save that. Okay, is execute ready is our function. So let's come down to the execute button. This is what we need to swap out. And in fact, you know what we're gonna do? We're gonna comment out that code. I don't wanna remove it just yet, because it was our old version. We will remove it when we're good and set with the new one. Also, I am gonna ask Bomber, you don't need to tell me now, but I'm gonna ask you later. Oh, Creative Sophia, how you doing? I'm doing well. We're getting some code going for our Enigmatica automated crafter setup in Computercraft. We're gonna get over there, I think, pretty soon to test out this new little bit of functionality. But Bomber, I was gonna ask you, at the end of the stream or after stream, let me know if the stream was fun and enjoyable. So Sophia, this is something I'm testing out. Normally we play a game. We're doing a little different this time. So you make all the functions then, write the code so it knows when to call the functions. Yes, exactly, right? So what we're gonna do now is we're gonna call our function of is execute ready, and if we remember, let's actually go back up and look at it again. This is a parameter, so we're gonna pass this into the function is execute ready. Well, what is the item table that we need to return in there? Well, we happen to have it down here in our draw subcrafts detail. So we have a function somewhere. Somewhere. I'm zoomed in, so it's a little different for me to look at stuff now. I feel like it's towards the top. Right here. The full mats table. So we have a different function called build crafts table, which is building the crafts table and the full mats table. This is our material table that we need to pass in to the function that we just wrote. Come down, we go to is execute ready, full mats table. Okay. So if this returns true, right? It's a true or false return statement. Then end. Okay, so here's our new little if statement. And all we really need to do, honestly, is this. I don't think there's anything else we need to do just yet. It's not perfect, and I'll tell you why it's not perfect in a moment. It's not perfect because it's passing in this items table. We don't want to do that anymore. What we really want to pass in probably is the crafts table, and then, right, this was one of our bullets. This was one of our bullets. We need to have the execute button needs to initiate a new crafting sequence, and we don't have that today. Which means we don't know exactly what we need, but I'm pretty sure we just need to pass in the crafts table, not the items table. But we're going to leave it alone at the moment. The only thing we're testing right now is will that button deactivate and activate when it should. Maybe you can help out with Twitch custom graphics and branding? Maybe. I don't necessarily think I need anything at the moment. I do appreciate it. You're certainly welcome to stay and chat, and maybe it would be something that we would need in the future. Let me know. That's our Discord channel if you want to join it. Okay, so we've saved this. All this should do is change that button to be active or not. Let's actually take a look at the execute button before we go back into the actual running program, because we do already up above, we define the execute button, and we are defining it as colors. The text is black, the background is light gray, and we say available false. This is important, right? Available false means it's not active, which means if we click the button, the code that handles the listen event of the click, which we can take a look at in a minute, it'll say, oh, it's not active, so we're gonna ignore it. But down below, our new one on this execute button, available equals true, meaning it's active. Let's come into our code and take a look. We gotta terminate the currently running code. So actually, let me explain something too here. This Visual Studio Code window, this here is hooked up directly to the file that's inside the Computercraft directory in our game save. That's why we're able to edit it right here. Inside the game, we could have also written this. It's easier to do this outside the game. Yeah, I don't have the Discord open. But I'll check Discord after the stream. This program's kind of like Inception. Is it? I think the word you're looking for is recursion. So recursion in programming, and this clearly does recursion. When you start here and you go inside of something, and then that goes inside of it again, but it's like a new layer, and it goes inside of it again, a new layer, that is recursion, and this is absolutely doing it. Every single time we have a new item as a subcraft, it's recursively calling the build items table, and then adding more details and more details to our tables. But I think we're good. Oh, but for recursion, you meant like we were in the machine from being outside the machine, inside of a different machine? Yeah, kinda. I can see where you're going. But anyways, when you run code, hold up. We got something to take care of outside. And before we go out there, we're gonna re-add our trinket of mind burning. There's a lot of them. There's a lot of them, guys. I don't want to kill the one that's got the banner, but we'll kill all the rest of them, and then we'll let the fire from my fire mine kill the banner guy. Okay. Man, those guys are just super annoying. I will take his banner, though. Okay. Remind me. So here's the thing. This is not running on a server, which means when I hit escape, it pauses, and I try not to alt-tab out if I'm not paused. I don't actually like running my game while I'm AFK, for various reasons. Yeah, we had a raid. Okay, so let's, if you have the code running, and you go out of the game and you save new code, it's still technically running the old version of the codes, which means every time we make a change, we have to terminate the previously running version of the code. Not a big deal. We'll start up a new version. We'll hit crafting. Let's start with the aluminum sheet metal. We know we have enough items to craft it, which means the button should be red. Remember, the button was red before we made the change, so if it is red, it might mean we didn't do anything at all. It's red. But if we go back, and now we queue up the wired modem, which we know we're missing items, it should be gray. Look at that. Look at that. And I'm going to click the button, and I know it's not going to do anything, and in fact, we're probably going to see execute was pressed. And we crashed the program. I need... That is a new item on the note list of, fix, execute button when not ready. That's okay. That, honestly, that's going to be part of our new craft experience. Like, it's actually going to get handled on its own. But we've crashed the program, and that's okay. The thing that we wanted to do, the change we made, actually worked. We saw it right there. And actually, we need to test it a little bit more, right? I'm not going to click it this time. I'm not going to break it. But we're gray. The other thing we need to test is we need to test that it can go back to red. right when we have all the items we need. So let's go to the wireless transmitter. It has gone back to red because we have all the items we need. Okay, that's great. Well, yeah, and actually I knew it wasn't gonna work because it's just not really, it wasn't set up to work. And we had the value, right? Execute ready was false, or technically the available was false, which meant it wasn't active, right? We do check that value, although I don't check it clearly in the correct place. That's why we crashed. That's fine. But the next thing we need to do is we need to increase this so that our aluminum rods or our advanced processors are above our have number to make sure that this can change. So if I increase it by 1, we should still be good. If I increase it by 1 more, we should still be good. If we increase it by 1 more, we're gonna break the aluminum rods, right? When I say break the aluminum rods, I mean we're gonna need more than we have. And it worked. We're desiring 4, but we're missing 2 aluminum rods, so the execute button is grayed out. Perfect. You know what? I think we're missing. I just realized this. The music at the top. This should say that it's from the Hard Space soundtrack. I might be missing a line. We'll look at that later. It's not important. Why is OBS not showing the code window? Okay, back in the game. Back to code. Come on, OBS, what's going on here? Oh, hold up. I'm moving around in the game now and OBS looks frozen. OBS looks frozen. Let me try something. Okay, that's the game capture. That's display capture. Display capture is broken. Let me turn it off. Turn it back on. Here we go. Weird. Okay. Code. Back to code? Good. We can see the code. Okay. So, we can cross off one item from our list. Relogic the execute button. Chunk. Come over here and instead of having a star, let's put a dash, and that dash will indicate that it is done. I do Alt-Z over there. Let's do the next item. What do I want to actually work on next? Well, you know, I kind of feel like we could either start working on the inventory monitor UI, but we're not going to really have a lot to display there unless we really work on the execute logic. So I think we have to go there. It's going to be the more complex portion, honestly, but execute button logic to initiate new craft sequence. No, not the same symbol. Current task. There. Now everyone knows what my current task is. Hey. This is crosscode here. Early Access 2015 version. I wonder if that's different than the game version that we're playing now. But also, let's delete this. We don't need this anymore. I do want that initial comment. This is just a code readability thing, so that if we ever take a look at this again and we can't remember what this little bit does, it's just saying if all materials are present, enable the button. I'm actually gonna execute button. We're gonna add a little bit more there. So we have this local function craft down here, and before we look at that, what happens when you click the execute button? That's what we need to look at. So, the way that Computercraft works And let's actually go back to the game real quick. You won't be able to see this. I don't think we have any log messages for it. No, we do. Okay. Anytime you right-click on the screen, okay, I'm going to come here and I'm going to terminate the program so it doesn't slide on us here. Monitor touch. This is an event, right? So the computer has events, and monitor touch is one such type of event. We have touched a monitor. Where? Well, side right, the monitor is on the right side of the computer, right? Because this is the computer. And where? Where did we touch it? Well, we touched it at X 46 and Y 23. Those are the screen coordinates, not a button. So we have a function that listens for these events, and I'm printing these out to the screen so we can like troubleshoot things. However, if we clicked on an actual button, let's rerun the code. Rerunning the code, I'm gonna click here, not a button, right? Not a button, and then these are just different debug statements. I don't really need this many, but they're in different functions. Let's ignore it. Let's click the crafting button, and it's gonna say, look, monitor, side right, X53, Y30, crafting pressed. So it knows that I pushed a button, and the way that it knows if I pushed a button is it's literally looking to see what screen are we on, okay? We're on the monitor screen, the very first one. Okay. Do I know of any buttons in there? We have a table of buttons and their positions. And so then it's looking through that table of buttons and their positions to say, hey, do any of the press event XY coordinates match up with the space of where a button is? If so, then a button was pushed. And actually you'll see this says not a button because this one here is for the main screen, and this one here was for a different screen, and this one here is for a different screen, and this one here is for a different screen. So that's how that works. So if we come down, like here's our our button table. This is the crafting button. Let's take a look at the crafting button since we just pushed it. When we push the crafting button, it takes us to a different window. But first, let's take a look. We know that this button is on the main window, right? This is important to let us know if we're on the right window when we're clicking a button. The position of where the button is at is listed here as well, and the colors that are there, because we actually use this information to also draw the button. But this is valid click. We have is valid click for multiple different things because they actually do slightly different things. However, right, all it's basically doing is saying, hey, is the window, so like main window, was it visible? And if it was true, which it was when we hit the crafting button, we'll continue on. If MX, which is our position that we've passed in on this valid click, so this is from our click event, if the X and the Y value are within the parameters for where the button resides, which is what these are. So if everything is true, then we're going to do the thing, and we're going to return true and the text of the button, right? So crafting. And then if we go to is valid click, which is down here, listen for touch events. If is valid click was true, all of those things we just looked at, then it's going to do the logic. And the logic for this is if the option was crafting, which it was, right? Because we could technically have other buttons, and we will have another button in the future called clear or cancel or stop. One of those, right? We will have that button on that screen, so we'll have to have a new option in here for that. Also, you can see the back button code was there. But anyways, it would then swap to our craft window when we hit crafting. It's a very similar thing for the execute button, but we have a different event. Listen for touch events execute button. We could get clever and have all of these different listen events, listen functions be probably one specific function that then handles all the different buttons and the combinations and what they're supposed to do. We could. I opted to go a slightly more lazy route and then have each one be their own sort of function. So that's where we are at the moment. So is valid click execute button. Let's actually go look at this, because this is probably what we want to change a little bit of. Is valid click execute button. So all we're checking at this moment is, was the window visible? And did we click in the right spot? It actually goes all the way over here. That's all clicking in the right spot. If all of those are true, then we return true. And the text of the button. But I think really, man, and there's a little thing on each of these, and I don't like it, and I'm gonna fix it. Really, we now need to have an additional check, and we could make this part of the original if, but we're gonna do a separate if. If we've passed in the execute button, and we're going through. What did we actually pass in? We passed in execute button here. Execute button is technically a global value. That's why global values frowned upon in professional code. I do have global values in here. And honestly, part of the reason I have global values in here is because it's Lua, and that's not an excuse, really. It's more so that I don't kind of like some of the ways it passes values around, and so using the globals is a little easier. It's another lazy thing. It's not the best way to do it. But we're passing in this global value of execute, and what we really need to check is available. Let's copy that, because we need to see if it's available before we do any actions, right? Is valid click on the execute button? Well, if it is, v.available has to be true. Then we return true. Otherwise, we end up down here and we return false. Let's save that. We should be able to test this right now. That was right, this was the bug that we encountered. Good, we're still running. Let's click wired modem. We know we don't have enough items. It's gonna be grayed out. Let's gonna hit the execute button. We're gonna come here, and we still broke it. Table expected, oh. Okay, so this actually says wired modem at Lua 34, which means we've gotten further than I think we should have, because we've gotten ourselves into the wired modem, line 34, which means that we have called this craft function. We shouldn't have gotten there. Let's go back and take a peek here. I saved it, right? I did save it. This is code debugging right here. So what we're going to do is we're going to say we have a problem, but not the right problem. Yeah, kinda. This should have come back false. Print B click. That's what execute. It says true right here. This true. That's printing that B click. Okay. So what we're gonna do real quick is for every item in pairs execute button, technically execute button is it's a tape. Okay, so this is a little wonky too, and this is because I have I'm reusing a common function for drawing the buttons, right? And the function for drawing the buttons takes a table of tables, okay? So this here is a single table inside of a table. And for execute button, we're only ever gonna have the one. But for other buttons, like if we come back here, these here, there's one table that houses all of these different buttons, all 6 of them, right? So we have a table of tables, which makes the code over here sound a little wonky, but we just have to keep it in mind that it's sharing functions with sets of buttons. This one just happens to be a singular button, not a set of buttons, but it runs through the same code. So when we come down here to is valid, click on execute button. This is why we're doing the for loop. There's only ever going to be one item in this list. I already know this. So we're going to just print right here. This is just going to print it out. We're going to say checking execute button. And this is just for our temporary debugging. We're going to delete these. Print. We want to see v dot probably window dot is visible. That's going to be the first item that gets printed there, so that's going to be true, almost guaranteed. And then I want to print v dot text, and then I want to print v dot available. And theoretically, this should be false. Let's restart our code. Autocrafter. Crafting. Okay. Let's come to our wired modem. Let's hit our execute button. We're going to crash again because we didn't fix anything. Wait, what? Hold up. You know what? I think we saved it, but I don't think we restarted the code. Let me click here, cancel. I've got too many other log statements. I can't scroll in this window. It's such a pain. It's such a pain that I can't scroll in here. Let's rerun the code and let's see if we can spy it. Execute. 1, 2. 1, 2. 1, 2. Execute. In. Stop. Did I get it? What am I expecting to see? I'm expecting to see this. Checking execute button. It's time to remove some of this stuff. So the crafts table after addition, let's remove that so we can get rid of all of this lines, okay? I just know where it is. I don't have to like search for it. It's gonna be up here in the build table. Crafts table after addition, we're going to... All that was a logging statement so that I knew what was being added to the table. Technically, I should delete this, but I'm going to leave it. I have some plans that I'm probably never going to get to of instantiating an actual logger that has debug statements and I can turn debug on and off. But we'll ignore that for now. The next thing I want to turn off is this. Inserting the item into there. I already know it works. Let's get rid of that too. Let's rerun the code. What do we get? How much stuff are we getting now? Checking if we know how to craft. Inserting to full mats table. So we still have a few more things to remove. This line. Gone. Inserting. Gone. Craft found for gone. Okay. It's all stuff that I know right now works. We've sort of demonstrated it multiple times. Okay, so I've got one more statement to remove, but this is actually going to make it a lot easier. When I hit this execute button now, what happens? Checking execute button. Function. Okay, so I didn't output that correctly. That's fine. But we see that it's execute, and we see that available is false. But you know what else we see? The code didn't break. Execute, execute, execute. Right? The code hasn't broken, which means I don't think we restarted the code after I saved it. So it worked. Thanks, Bomber. Hydration check. Okay, so if we come all the way back down, our code here worked. We can we can remove this. I'm going to totally remove all of that. I don't care if we keep it in, because I already know it now works. We've checked our execute button. If it said available, it should move on to the next bit of code. So let's go back to is valid. Click execute button, which is this one right down here. So listen for touch events. So you know what? We're gonna get rid of that. In fact, I should probably just delete it. I'm just gonna delete it. Bop, gone. So B click. What does B click mean? It's button click. This is actually another thing in like professional level code. You should really avoid anything that's not clear. So like this probably should say button click as a full word, because it makes a lot more sense than B click. But here we are. When you know the rules, you're allowed to break them. I think Abraham Lincoln said that. Okay, so if print the option, I think we're gonna leave this in here for now. So if the option is execute, meaning we're listening for an execute button event. If the option was execute, meaning it wasn't a different button, then we're gonna say, yep, execute was pressed. We'll leave that there. This was an old comment that no longer applies because we have changed up the code quite a bit. Our global execute button object currently has an items table, but we no longer want it to have an items table. We want it to have our crafts table. We also don't want to call this current craft module.craft anymore. So the current craft module is like our aluminum sheet metal.lua. This is the module, and it has its own craft function. We don't want to call this anymore. Not yet. We will call it, but now we need to call our crafting orchestrator, right? Because we need that orchestrator to do all the subcrafts before the main craft. So that's what needs to happen here. We do actually want to swap our current window to the main window. That is true, because our main window is going to be our monitor window where we can see what's happening. So we're actually going to just comment that out for the moment, and we will delete it. I'm going to delete it. But what we want to do is we want to call our craft orchestrator function. Pass it the drawer controller, find type, and the crafts table. Okay, so where are we going to get these? Well, we already have the drawer controller being passed. We have to go all the way back up to where we set our button. Right here. Oh, no, actually that... Again, it was a bad thing. I should really be like inserting our drawer controller object into a value and like passing it along, but it's a global value. Sue me. But this items table is no longer going to be part of our button. Now we need our crafting table, which we have right here, crafts table. This is actually doing it the correct way. This is setting a local value and then passing it along. And I don't like that. Go back over where you were, please. I want you to be lined up with that. Thank you. I think that's good. I think that's actually great. And in fact, we're going to change this up just a little bit so it's like a little bit more readable. We're gonna put this stuff down here. Perfect. You can separate. Because they're inside these brackets, you can separate them on multiple lines, and it's going to be fine. The interpreter is going to know how to do it. You know, Abraham Lincoln quotes are all the rage. Okay. So that's great. So now we're passing in the crafts table. The crafts table is going to have the, like, aluminum sheet metal would be listed there if we need to make it, which we don't, which we won't, because we have a lot of aluminum sheet metal in our system right now. Eventually, though, we might need to, so it might end up in that table, but it won't for the current craft. So if we come back down here, let's call our function that we don't have yet. So we're going to make up a name right now, and I think we want to call it Craft Orchestrator. Honestly, like we want to initialize, we want to kick off the Craft Orchestrator. So I think we're going to just call it Execute Crafting, though. So Execute Crafting. And we're going to pass in our drawer controller, object, and our crafts table. So if we take a look at this, the items table. Oh, you know what it is? The items table, because it was a global value, but we're not doing global values anymore. I need to do just a tiny bit of little work here. We need to get our crafts table outside of our execute button. We know that execute button. This is a bad practice too, but I know the execute button is a single object inside a table. So we're going to do the first item inside that table, dot, and then, oh shoot, I need to go back up to it because I think we need to do something a little tiny bit different to it. Crafts table. You see how I didn't assign it a value. Crafts table gets crafts table. Done. Okay, what this means right here is this now has a name. Before it was just an element. We could have found it by its position in the table, like numerically. We also knew it was last, but we don't want to rely on that. So now we know it's called crafts table. So now it's being passed as crafts table. Fantastic. We're gonna call this crafts table. I think we're gonna delete this. I don't want this anymore. So now we need a function that's called execute crafting, and it needs to be this is a craft orc. What? Oh, for orchestrator. That goes back to one of those other bad tendencies to like abbreviate names or come up with like acronyms or something. It is better to probably spell out orchestrator than it is to say orc. But we went with execute crafting because when you make a function, the function should really be around an action, right? So I could have said execute craft orchestrator, but I think execute crafting is good enough too. I think they both work, but we need to write the function. And Lua, we're going to talk a little bit more about basic programming or coding know-how, something. So there's two sort of main different versions of code, right? There's a code that's compiled, like your ++ or your Javas, right? What that means is I write the code, I have to save the code, and then I have to compile the code into a new file that can be run by the executor, right? Whatever language you're in. Or there's an interpreted language, which Lua is, meaning we write the code, we save the code, we don't have to compile it to a new file. When you run the code, what it does is it goes line by line through the file, it interprets it at runtime, and then that is able to run it. But one of the things that means is, in order for this to execute correctly, the whole program, if we call execute crafting down here, we cannot define local function execute crafting down here. We can't do that because what would happen is the interpreter would get here and it would say, oh, I don't know what this is, and then it would basically crash. So we have to have this defined above. We could literally define it right here. But I think I want it higher in the file because this section of our file is all of our listen for events, and above that is all of the valid click events. So we're going to put it up higher. In fact, we're going to put it right here. I had a function that was not doing anything. This whole function, it was a placeholder. I thought I was going to use it. And in fact, this sort of is going to do what I thought this was going to do. But this is basically garbage. I don't want to delete it until I reread all these. I might have something good in my notes here. You can imagine a little orc running around with a clipboard telling little machines to craft things. I'm trying to figure out a way if we can do that. Because there are some entities in Enigmatica. We wouldn't be able to get a little orc, right? But we might be able to get like a golem or something that could like run to a machine and maybe push a button. And like technically a drone could do this, right? A drone could fly to a machine and push a button, and that pushing the button would be telling it to craft the thing. You like that organization clumping each type of function together? Yes, me too. And you know what? You know what? In a production level code, I would actually extract this into its own file. All of these valid clicks, I would probably put the valid click. Again, like this could probably be one function and handle each thing individually. I made them their own separate functions, and it kind of bothers me that I did it that way. The listen for events are actually separate enough that I liked keeping them separate. So really, like in production code, I would move this to a subfolder, to a subfile, and I'd probably call it touch event listen helper or touch event listener utilities, right? I would probably call it that. And then we would import that file into this one, which importing happens at the top. And you'll see we import all of our, like aluminum sheet metal is imported here, and that's how we can access those functions. So yeah, another like, if I was doing this for like professionally, I'd do things a little differently. Some of those things, they just take additional time, and again, because I'm the only person who's going to use it, I don't mind if it's kind of a mess. Seems like Lua is very easy to debug compared to compiled language. It can be, yes and no. The way that we just debugged, okay, the way we just debugged, you could do in another language too. The real difference is, let's say we were doing Java, right? We could put the same print statement in, and we could print lines to our console as we're running, and we could see the same exact thing that we were seeing in Lua. One of the things, when you compile code, okay, and I want to be very careful I don't say something incorrect here, because you know what, it might be different for each language, and I might get something slightly off, but the basics of when you compile code, it's compiling the code to a machine language, not to the readable, writable language that we just did. It's actually rewriting it, and like function names don't exist in the same way, like they might just be random like strings of characters and stuff. And it reorders things as well, and then the whatever the executor is that runs the compiled code knows how to read that and operate on those. And so there are certainly times when you have compiled code and it tells you like, oh, there's a problem on line 42. It might not actually be your line 42, although I will say most programs probably tell you the correct line, probably. The other thing too is if we had this is Visual Studio Code, okay? If we were running the program in an actual IDE, so this is a text editor. It's not really an IDE, it's really just a text editor. But if we were running in an actual IDE and we were able to run the code in that program like Visual Studio or for Java, Eclipse, right? You may have heard of those. If you were to run the code in there, you should be able to debug it and actually step through the code line by line, literally not moving to the next line of code until you hit a button to do so, right? Which actually makes debugging way easier than what we're doing here, although this is also fairly simple debugging. You went to college for carpentry and learned that a professional carpenter's house is usually filled with a hodgepodge of fixes, barely in building code, and programming reminds me of that. Yeah, probably exactly that. And here's the thing, right? As the carpenter does, and my father's like, he has his own construction company. He's a solo though, so he just does his own thing. He has more work than he can do and all that kind of stuff, and he does very good work, and he makes things, and I've said this before. I don't have it right next to me here. I'd show you. I mean, like, I have a guitar that he made, and it's really nice. It's a nice electric guitar. He actually used to make them with another person and sell them. Yeah, it's sort of the same thing, right? His house, he's redone himself, a lot of it. Like, we had, growing up, we had a family room above our garage, which was where, like, my TV was, and, I don't mean my TV, like our TV. It was where our big screen was. Back when your big screen was a projection, right? Not a wall mounted or anything. And this is where my Xbox was and stuff. That was mainly my room and my dad's room. My mom didn't usually go up there, but he's renovated that whole room. It's now actually my parents' bedroom, and he did nice tile for the bathroom that he put in there. Right, he installed a whole new bathroom in there, and it's got like heated floors, and I really like those heated floors. But yeah, I mean, I'm sure, absolutely right. He probably didn't do everything exactly the same way he would have done in one of his clients' houses. And this is the same thing, because I'm doing it myself. I'm doing it for myself. And the stakes are low, right? This is Minecraft. If it doesn't work, or if there's a bug every now and then, it doesn't matter, right? If I was doing something different, so I can't show you easily, but like I have, I've got 3D printers right over there on a table, right? And I haven't used them in a while. But I was monkeying with code on, it's called Octoprint. And Octoprint is something that someone else wrote, but I was monkeying with the code to customize it for myself, and I did absolutely spend a lot more time shoring the code up for that, because the stakes are a little higher with a 3D printer, specifically an FDM, which means it's melting plastic. There are elements that get very hot, and you don't want to have a runaway heat problem and cause a house fire. So it comes down to the stakes that are involved too, right? Speaking of 3D printing, right? 85% of the reason I got into 3D printing was for D&D miniatures. 85%. I had interest for other things too. And I have a lot. I've mentioned this before. I have a lot of D&D minis, but I went from FDM printer to a second FDM printer, and then I went to a resin printer, which uses a liquid, and it uses UV to cure the mini as it's printing, right? And I was actually thinking, because I'm starting up tabletop gaming again, if we get back into it, which I might. I mean, it's gonna take time, and I haven't done anything in the hobby now in a little bit, so it's gonna take me a little bit of effort to get back into it. But if we do, and we have things printing, like, while we're streaming, I might try to set up a secondary camera. So, like, I'm here, but, like, over there in the corner or something, we could have, like, a secondary camera on the print, and you could just watch the print going back and forth. Maybe. It's been a thought of mine. It's only a thought at this time, though. Yeah, I think a print cam could be pretty cool, especially depends on what you're printing. Now, the problem is if I'm printing D&D minis, they're in my resin printer, and the resin printer has a hood, and you can't see it while it's printing, and that's on purpose because you need to regulate the temperature and you need to regulate the light level. If UV light is coming in, it's gonna change your exposure levels, and that's not good. So we wouldn't be able to watch that one. But, now thinking about it, we could even have, like, we could have mini streams. I would want to set up a whole new, like, camera setup. But, like, we could do things like where I'm cleaning up minis, and maybe we could even do, like, painting streams. I'm not I'm not a big painter. I wanted to get into it really bad, and I've only done a few paints. Hold up. I'm trying to see if I have one. No, I do. I don't know if you can see behind the screen, but I have a shelf behind my green screen. These are FDM prints, not the resin, so they're not actually as high quality as they could be. Man, these things are a little dusty. Sorry. This is an owl bear. Can you see it? Can you see it very well? Pay no attention to the man behind the screen. So this is an owl bear. I have a painted version that I also painted, but like these are the extents of my painting skills. It's not amazing. It's not terrible. In fact, I actually quite like it. However, are the eyes being green screened? I don't know. So yeah, I would use these on the table. In fact, I did use these on the table. There's actually a couple other little prints back there too, but not my good ones. I also have this one. Also an owl bear, but it's like in attack mode. That's mostly what I got back. My main minis are like in a box over there, just because we haven't played since COVID, so I haven't even pulled them out. Yes, assume attack mode. But yeah, so those are from the melt plastic, do line, layer by layer up, and the quality on those is lower than the resin printer by far. Okay, the code. Back to the code. I don't know how we got on that tangent, but we're back. We need to figure out how to do this execute crafting, and we already know that we're passing in from down below. In fact, I think it's worthwhile to relook at it again. What I did here is I double clicked on execute crafting to highlight it, because now over here in our bar we can see where it's called. We pass in drawer controller and we pass in crafts table. So let's call those here. Drawer controller and crafts table. Great. So what do we need to do? Let's write it. Let's write it out. This is one of my best recommendations for writing code, but not just writing code, but literally doing anything. If you have something that might be moderately complex in any way, write out your steps. Even if you don't know how to accomplish the end goal of each step, write the step out, right? So the very first thing we need to do is we need to get the last item. No, let's rephrase this. Get the item to craft from crafts table. Let's do a sub-bullet. This should be the last item in the list, because we know I know I'm adding the crafts sequentially. So we start at the top. We want to craft the wired modem, right? That's our top level craft. In order to craft the wired modem, we need to craft a network card. So network card's going to come into that list below. Let's just say it ends there. That means the last item in the list is network card. We want to start with it because it's needed for the top level craft. So get the item that we need to craft out of the crafts table. Should be the last item in the list. Perfect. What do we need to do next? Well, next, we need to rebuild our items table. I don't know if that's what I want to call it. We need to rebuild our... Actually, I have a function. It's way up here. Go look at it. It might be called rebuild item table. Where are you at, function? Rebuild inventory table. That's what it's called. Rebuild inventory table. Let's do that. We got to go down back to our execute function that we're writing. Rebuild our items table with our function that we already have. Rebuild inventory table. All this does, it's really simple. I wrote it as a function anyways. It's going to our drawer controller, and it's just saying, hey, get me all your items and put it in this table for me, and then I'm going to pass it back. Rebuild our items table. Why do we need to rebuild our items table? Because we need to get the current count and position in drawer of the materials. Right? That's what we need to do. And then let's go look at aluminum sheet metal. And then we need to call that crafts craft, right? And that crafts craft is this. It's literally, so we would say aluminum sheet metal dot craft, and we need to pass it in the drawer controller, and we need to pass it in the items table specifically for aluminum sheet metal. And the items table would be it would be the drawer slot and the amount that we need. That's what we need to know in this at this stage. So we probably need to calculate before that. Calculate. Oh, actually, hold on. Are we already storing this? We could be. I don't think we are. I need to go to my crafts table. Where are you at, crafts table? Crafts table. So this is the table that we'll have. We're going to know the tag name of the item to craft. We're going to know its display name. We're going to know its module, because we're assigning it there. And we're going to assign the total crafts. Perfect. With total crafts, we can calculate the rest of the values. And we're going to recalculate them. I could probably calculate them here. Maybe we should. I could probably calculate them here and put them in to the table here. That's a good question. If we calculated it here, we would really only need to calculate it once. But no. I think we want to calculate it later, because that's going to tell us for certain how many we need, and then we're going to be able to compare it against the current exact count of how many items we have. So I do want to pull out total crafts. That's going to be important. Now I got to find our function again. It's down here somewhere. Down here. Calculate. What we need and how many. Comma. Build item table. So after we do this, we need to call module.craft. And then we probably, before we call module.craft, we want to calculate. Actually, maybe we call it there. This would be something that we could write right now, I think, and get it to work, and then we could enhance it with monitoring if the craft is complete or not. That could come a little later. So let's save it there. I'm going to take a real quick break, like at most, and I'll be right back. owlbears attacking. Not good. Owlbears are scary. I had a campaign that was it was a short one, and we ran a module. And in that module, there was a ruined castle fortress thing out in the forest. And there was a door. There were like bandits who had been using it, I think. It's been a while. But what I do remember is that there was an owlbear inside one of the rooms and the door was like shut and locked, and they had been keeping it. I don't think it was their pet, and they had been sort of starving it. I feel like they were going to try and use it as a wild, ravenous creature to attack something, right? One of the players gets the door open, opens the door, owlbear in their face. They slam the door shut and say, I think we'll just leave that one alone. Something like that. It was pretty funny. I do want to put, though, the note down here. We need to initiate crafting monitor. Watching for craft complete or something. Something like that. That's coming later. Okay. So we need a loop, because we need to do a we need we need the crafting monitor in order to correctly do our loop. That's okay. We'll put it in a broken state and test it out broken. We're gonna start our code down here, and we will delete all the stuff above when we get there. So there are two different kinds of loops. There are for loops, and in Lua, there's a concept of a for each loop, and that's for each element of an array, of a list. Every element, we're going to do something on it. In Lua, that's the for in pairs. Yes, this is cake, money, seagulls. So we have the for each in that for in pairs. We have a for loop, which will loop over something a certain amount of times, and we can sort of specify by saying start at 1 and go up to 10, and when you get to 10 you stop the loop. There's another kind of loop called a while loop. And a while loop, if you did while, it does while something is true. So if you literally wrote while true do, this will never stop. It'll run forever, which is actually good sometimes. And in fact, let's scroll to the bottom of the code, because look, we have a function here called endlessly. Draw the subcraft details. While true, do that. We want to do that. That's a good thing in this situation. But at other times, you will get yourself into an endless loop that will break your code. So we don't want to do that. But we want to while something is true. While something is true. And that thing that we want to do is true while crafts table, while the crafts table still has entries, while it still has anything in it, we want to keep looping over it. Because what's going to happen is we're going to do a craft, and when we're done with the craft, we're going to delete it out of the table. And then we're going to end the loop, and we're going to start the loop again, and we're going to see, hey, are there still items in the table? If there is, we're going to keep going. If there isn't, we're going to stop. But how do we know if there's still something in there? Well, let's go ahead and grab ourselves. Can I pull you over to the window? Let me get stuff going here again. We're gonna do Lua, and then specifically, what do we want? We want a table length, right? Array size. So, in programming, actually, hold on. Let me talk about this real quick. This happened earlier today. Not to me. I just watched it. So I was watching another streamer, because I put streamers on, usually in the background while I'm actually working. And I happened to look up, and the streamer had said, "Hey, is anyone in my community a programmer? Can anyone work with the Twitch API?" And then they said, also, you know, I'm also interested. Is anyone in our community like an artist or can do asset creation and animations, right? Stuff like that. Because they were looking for people who were part of their community who they could commission to do work for them, right? And this person is a full-time streamer, and they frequently have, you know, over 500 viewers, you know, so they're not small. They're not like me. And anyways, in the chat, someone pops up who, I don't know if they were even a follower of this person, right? But they pop up in chat, and they're like, "I'm a programmer, something, 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 but I'm unemployed. I could really use side gigs or something," right? So they were like trying to put their name in the basket, and that's fine. But the very first thing that kind of flagged something weird to me is, you are an unemployed programmer. That's not a thing that... I'm not saying you can't be unemployed. And there's people who get laid off every day in our industry. But our industry is also highly competitive in the sense that, like, if I wanted to switch jobs tomorrow, I could probably go find another job. There's so many of them. And now, because remote work is so much more, like, accepted... Like, I could probably get work almost anywhere. Like, it's crazy the way that the pandemic has changed my job market. So like, that was the first thing that tipped me off. I mean, and again, that wasn't like a red flag to me. It was just like, oh, you know, great. But the next thing they said, the very next thing is what really flagged it to me as weird, and I'm not sure if that person actually is a programmer, because they said they were boasting. And this is a paraphrase because I don't remember exactly how they said it, but they're like, "I know 26 languages." You know, and then people in chat were reacting to this like, "I didn't even know there were 26 languages." And other people, "There's way more than 26 languages," and blah, 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 blah. But the point that I come back to is, if you're actually a coder, you would never, honestly, go and tell someone, "I know 26 languages." You would never say, "I know 5 languages." You would never go and say, like, you would never try and boast and say that, because here's the thing. No actual coder is going to know 26 languages, and that's what we're looking at right now. I'm using Lua, and I know parts of Lua, but I would never go and tell you I know Lua. I know how to use some of it, right? And so, as a programmer, it's way different. A language in coding is not the same thing as, like, learning Spanish or French or Japanese, and in the sense of knowing the language means you're fluent in it and you can, like, go have a conversation with someone. Not at all. Being a coder means I know coding practices, paradigms, factory methods, methodologies, stuff like that, right? I know if something is feasible, if we can do something, and then I, as a puzzle solver, coders are puzzle solvers. We then figure out, okay, what are our stipulations here? Oh, well, our stipulation is to use Lua, for example, right? Great. Now I need to learn how to do it in that language. And, like, I might know very well another language, and I might know how to do it immediately in that other language, and it may work in a similar way in Lua. And it may not. It may be very different. But, like, That person kept going on. They went on for like 5 or 6 more messages, like with chat and stuff, kind of like talking about things. But like part of me wanted to like not publicly call him out, but like send that streamer just a private message being like, I would be wary of that person if you were gonna like actually commission them for something, because they didn't sound like they really knew what they were talking about. Yeah, if you know 26 coding languages, get a job. Sure, exactly, right? If you were legitimately an expert in those in 26 languages, right? I would assume you are a very good coder, right? Because like, I can be a very good coder and not be an expert in a language, right? And what that means is I'm gonna know the right ways to do something conceptually, but then I need to learn how to do it inside the language. And it is possible that I'll do it in the language in a way that's fine and works, but it might also be possible that there was a better way to do it in the language. The expert in the language would know all the little intricacies of like, oh, no. In this language, what you did is fine. However, it's slow. You want to actually do it this way and this way and this way, and it's faster. It's more performant. It's going to take less operations, or it's going to hold up the stack, you know, the execution stack in a shorter amount of time, or who knows what, right? That's what knowing a language to me means you're an expert in the language and you know a lot of the little intricacies of it. At one point, I would have told you that I knew JavaScript. I did a lot of very complex things in JavaScript, which is funny. I mean, a lot of programmers, a lot of people like to talk poorly about JavaScript, and I don't necessarily blame them. And there are good reasons why they do that. A lot of it, though, stems from JavaScript's past and not its present. But here's the thing. I have switched positions and switched jobs since then, and I would not tell you anymore that I know the language just because I haven't been using it. That isn't to say that I couldn't write something in it right now if we wanted to, but I don't remember all of the little details about it, or exactly. So what I would do is I would look it up, and that's what we're going to do right now. We're going to look up. I know we need to get the table length. How long is our table? How many elements are in there? These are how many crafts we need to do, and we're going to look it up and figure out how to do it. One of your favorite math YouTubers, Matt Parker, has a video about how a viewer made his code thousands of times faster. Yes! Aha. And there is absolutely... Here's another funny thing, right? There are mathematicians who code, and there are programmers who code, right? And do math. And they write very, very different programs. I would tell you I'm proficient in math, right? But I did not get a math degree, although I did take a lot of math courses. I heavily considered having a dual major, but I decided to graduate early instead. But so I almost also got a math degree, right? I was pretty proficient in math for quite a long time. It's actually funny. My father used to be a math professor at a college as well. So he helped me with a lot of my homework, and that, of course, helped me in school. But the math person who writes code, right, they may legitimately, I mean, I know... I'm not very close to what they do, so I can't really comment on it a lot, but the code that they write is very different, and it's because they didn't get a coding background, and so they don't know necessarily the best ways to write code, but they do know really good ways to have an algorithm run, right? And it's really funny, and it depends on what kind of algorithm it is you're writing and all that kind of stuff, but they might come up with a function that works really, really well at calculating some astronomically, crazy, complex something, right? And that's great. But then the rest of the code might be might be bonkers, like to an actual trained programmer, and their code might work, and it might actually work just fine, right? I don't want to take away their skills there either, but I have worked professionally with people who were a programmer in the field, right? And they were, doing similar jobs to what I was doing, but they weren't school educated. And there is a difference in the code that comes out, just because I'm going to say the foundations. If you learn something on your own and how to do things, you're probably not going to get the foundations exactly correct, or you're not going to get the same foundations or something. And that isn't to say what you're doing is bad. It's just different. Yeah, I guess I don't want to talk too much more about that, because it sounds like I'm saying poor things about people. I don't mean to be saying poor things about people. But back to what I was saying on this, though. So we don't know Lua like the back of our hand right here. We know some concepts in Lua, and we're able to code in Lua, but we need to get reminders on things. So what is the best way to get the array size? If we were in Java, not JavaScript, but Java, we would call array list. We'd pass in our array, and we'd do .length on the end of that, and that would tell us how many elements are in that array. But in this, we got to read this a little bit. This might be important. We cannot have a nil inside an array. We assume that an array ends just before its first nil element. Okay, perfect. That means we don't need to worry about a nil element, because we're not putting nil elements in our array. You know what's really funny? This literally isn't what I want. This isn't what I want. Let's go back. We're gonna look at something else. The funny thing is, I already know what I want, because I realized I did it just recently. And why are all these more complicated? So here's another thing in coding that you should always do. Okay, good. We're back in the game. You should always, when trying to learn like a new little concept, don't just immediately put it in your large bit of code, right? Because you may not fully understand what you did, and then that might break all sorts of things that you weren't expecting, and you might not understand where the break happened. So what you should always do is you should have, and we're going to do this down here, you should have a little testing code. Let's actually take a look. So inside this directory, this is just a folder, we have something called elementupdate.lua. And if we look at elementupdate.lua, all I did was I created a table, test table, and then I inserted two values in there of name A and name B, and I was trying something here, right? I wanted to see if using single quotes and double quotes made a difference, because in some languages it does. Probably written by a mathematician. No, it's I don't think so, but it's just not, it's not exactly what I was looking for. It was that page was talking about conceptually, I think, same thing, but I know that Lua has a shortcut to obtain it, and I know that because I found it out in something I was looking at last night. And if I didn't look at it last night, I wouldn't have known, and we would have spent time on that page. But I wanted to modify something in this table. But what we're going to do now is we're going to exit this, and we're going to quickly write, and we're going to write this in the game editor, instead of the other thing. So we're going to call this table length test.lua. Oops. We need to call it edit table length test.lua. So we're going to create a brand new file, which we've just done. We're going to create a local table. This is just going to be our test table, and it's going to be empty. And then we're going to insert table.insert into test table. We're going to insert it really, honestly, it doesn't matter. It's just going to be like a table, so we're going to call it, we're just going to say name. I don't really care. I really don't care. It doesn't matter what the values are in here. Name, and we're gonna say A. Ooh, that's bad. Name equals A. Gotta get rid of these two. Name equals A. That is our table that we're inserting. Close that off, close that off. We're gonna do another table, table.insert into test table. And I could have wrote this differently. We could have put this all on one line up here, but I like using these inserts. We're gonna do another name. And we're gonna give this one, because you're here, Palmer, there you are. You're now in our table. And close that correctly. Okay, so we know that there are now 2 elements in this table. Let's do a very quick for I, comma v in pairs test table do, and we just want to print v dot name. Okay, so if we run this, save, exit. What did we call it? Table length test. We got A and we got Palmer. You're a table insert. Yes, you are. So we know, we can see here. I mean, we see because we wrote it, but we also see because it's here. There are two elements in that table. Let's go back into table length test and let's do something different. I don't want to print them anymore. We already know what's in there. Let's get rid of this. This was just a demonstration to show that there were 2. There's nothing up our sleeve. We're not a magician. What do we have here? We have something I want to test here. So if we do print, and I think we do, what is it? Pound test table? Is that it? This could be wrong. But we're gonna find out. We're gonna call it again. Ha ha ha! Test table 2. So, I guess I want to come back here real quick. We got a stupid page. Like, demo to count the length of a table in Lua, right? So, like, they're creating this table, and then they're doing a for every item in table print. Size of table is size 1, and they're doing size 1 is 0. And they're adding 1. So they're looping through the table, and they're saying, hey, if there's an entry here, add 1 to our value. And then at the very end, we're going to print out size 1. And if there were 2 items in there, it should be 2. That is not the Lua way to do it. The Lua way to do it, and this is what I mean about knowing a language versus knowing how to code. Knowing how to code means I know I can loop through something, and I can keep incrementing a value to tell me how many items were in that loop, right? That's knowing how to code. Knowing a language is knowing that you can do something like this. # test table. And that wouldn't work in JavaScript, that wouldn't work in Java, that wouldn't work in C# or whatever, right? But it works in Lua. That's what it means to know a language, to know all of its little idiosyncrasies, and to know like its shortcuts, to know how it operates on things. And in fact, this might be shortcut for that. It literally might be looping through the table and just counting, but it's shorthand for it. And if I knew the language, I would actually know what that does. I don't know exactly how that works. So anyways, the code that we want to do is similar to what we've just done here. We want to do while test table. So while test table, the number, the length, the count of items within the table, while that count is greater than 0, do. And then we're going to like say end down here, and we're just gonna print. This is just for us. In table. I don't know. It's fine. It doesn't really matter. We just want to make sure that something happened here. And then we want to remove the item out of the table. Well, how do we do that? So we come back to our Google. Lua, table, remove. Insert and remove. And in fact, I'm sure I've actually... We do the table.insert all the time, but there's also table.remove. So we're going to use table.remove. And what are our parameters? So a pop operation is table.remove a. Insert at the other end of the structure, we use table.insert to remove from that end. Use table.remove a1. Oh, let's see what this does, actually. Table.remove a1. And it also, this one tells us the last two operations are not particularly efficient, as they must move elements up and down. However, because the table library implements these functions in C, oh yeah, that's another thing. The language Lua is running on top of the language C. We're not writing C, we're writing Lua. But it's running on top of C, which is funny. These loops are not too expensive, and the implementation is good enough for small arrays. Great. Up to some 100 elements. We're never going to have hundreds of elements. I say now, never going to have hundreds of elements in that table. So let's do a table.remove, and I want to remove the last item in the table. And I think what we can actually do is we can tell it test table, like that. So what this is saying, right? We've got one item in the table, we have two items in the table, and A is at position 1, and Palmer is at position 2. And if we try to tell it to remove, this should be 2, right? This is going to equate to 2 at the first time it runs. It should remove position 2 out of the table. I think that's what's going to happen here. So I think I want to also do a print of... We're in table, and we know test table at test table. So the last element of the table. Dot name. Close that off. Save. Oh. You know what? There's one more thing I want to do here, and I just want to do a print at the very end. That is end of loop. Sure. And in fact, let's do in table with space, and we're going to do dot dot pound test table dot dot elements. Okay, so it's going to tell us we're in a table with 2 elements. That's going to be the first time it prints. The second time, because we're hoping we've removed one, it's going to say with 1 element, and then we should never see 0. We should end the whole program. Save, exit, table length. I spelled length with an A. Length. What am I doing? Okay. 2. In table with 2 elements. Oh, I didn't put a space in there. That's fine. And then the name was Palmer. And then we broke. Great. Table expected got number. Okay. Table expected. That tells, so we're debugging again. Table expected, but we passed in a number. So I already know how to fix this. We need to, instead of removing the number 2, of course, we need to remove the actual test table itself. So test table element at number 2. That's what it is. Save, exit, we'll run the program again. And we've got ourselves into an infinite loop. Alright, what did we do wrong? So... Oh... No? Yeah... I know what we did. Test table... This is just the way that these functions work. I need to pass in the table that we're doing the operation on, and then we need to tell it what to remove out of it. I think that fixes it. In table with 2 elements, Palmer, and then we hit another bad argument. Number expected. Number expected got table. Okay, nope, that's right. That's perfectly fine. Hold on, let's go back up into our... Oops. Edit this. We gotta come back to here. I see what happened. The first time it told us what the problem was. It told us we gave it a number, not a table. And that was this first value. We forgot to pass in the table that we're doing the operation on. Of course. And now, the second thing is, what element of the list do we want to remove? And we want to remove the final element, which is going to be 2. And then the next time it's going to be 1. And if we had 3 and 4, it would start with 4, 3, 2, 1. Run it again. In table with 2 elements, Palmer. In table with 1 element, A. End of loop. This is how we want our program to run. This is how we want our actual crafting program to run. The crafting orchestrator. Start with the bottom craft in the list and move itself up. And this is how it's going to do it. It's going to do the bottom craft. When the bottom craft is done, it's going to remove it from the table. It's going to go back to the top of the list, the loop again, and it's going to go back to the next bottom of the list and do the next one. So that's what we're going to do. So doing little tiny small tests always teaches you exactly what you need to do and how to do it. There's a knock on the door. You open it. You see a package. Ah, this must be my numbers. You open the package. An IKEA table is before you. The IKEA table has lots of numbers. Has lots of pictures. It may be missing parts. Speaking of IKEA, my desk, which I'm not gonna show off, but it's actually 2 tables, and to be fair, they were kind of cheap tables. They're not solid wood or anything like that, and I thought it might be a problem, and it turns out it was. I have one table here in front of me, longwise, and then I have another table here, longwise this way, but it's shorter because it's up to the edge of the other one. So it's like a big L, right? My table's like a big L. I have 3 monitors right in front of me, and I mounted them on a mount that clips onto the table, and then there's a pole that comes up, and then there's arms that come off, and that's where the monitors are. When I mounted it, already in my head, I knew I'm probably going to have a problem here. And that problem was that I thought that the monitors were going to weigh too much for the clamp that's on the table. And now the clamp, the top of the clamp has legs, and it has 2 legs that come out. And I was hoping that maybe there would be enough surface area on those legs to disperse the weight enough that it wouldn't start to push the table in, right? But because the table's not solid, it ended up starting to deform the table after months. I mean, half a year probably, or so, maybe more. I don't know. It started to deform the table. So you got me on this tangent because of IKEA, but I went to Lowe's and I bought a 1/4 inch. Is it quarter? It's probably actually 1/8 of an inch. Yeah. Probably about 1/8 of an inch thick sheet of steel. That's about that big. And I put that there, and now the clamp is on the steel, and that is a lot more surface area. So I'm hoping that gives more longevity out of the table. When I ordered my table, right, I was looking for a new desk. My old desk was a big wood, like hardwood table. I mean, it's old. It's a really old table. It's over there still. But it's like, I'm trying to remember the exact measurement. It's like 36 inches high, which actually seems to be pretty common for a desk, for a computer desk specifically. But I found that, like, even when I'm in my chair, and it was this chair, it was other chairs, it didn't really matter. If I was in a chair, and I had the chair even at the highest it could go, which is not very comfortable for your legs, at least not for mine, because I'm not, like, over 6 foot tall, I found that, like, I would be instead of my arm being like this to get to the keyboard or the mouse, it would be like this, because I have to like reach up to get onto the table. So when I was buying this new desk, which ended up just being 2 tables, I was looking for a desk or table that was lower to the ground, and what I found was at IKEA I could buy a table, and then I could buy legs, like separately. And the legs that I bought are actually legs that extend. So I'm trying to remember the exact measurement, but I feel like I have my current desk at like a 32-inch height, I think, which means that I can put my chair with my legs at a 90-degree angle on the floor. I can have my arms on the armrest and then be flat straight over to the tabletop, and I don't have to do the T-Rex arms, which I think is good for carpal tunnel prevention. And that's the IKEA tangent for tonight. Let's move back. Let's write this code. Actually, I can probably just warp there. Factory. Blink. Nighttime. Let's sleep so we don't get any raids. And then pause the game and hit back to our crafting code. While craft's table is not empty, meaning, because we just found this out, because we just did this, while the length of craft's table is greater than 0. So while it still has elements, we're going to do our code. The Table Saga. Roller coaster of a story. Yes. And my monitor mount, sorry if that was loud because I brought it close to my face, it's also clamped onto the table. But I just took a piece of tile on the top and the bottom of the table in order to, again, increase the surface area of what the clamp and the weight is on, and that seems to be doing fine. It's also way less weight than the monitors, of course, but my monitors are also like water time. My monitors are like over 10 years old, and they're only 1080p. They're probably low refresh rate, and they're heavier because they're old. I really should upgrade. I really should upgrade at least the middle one, but frugal or whatever, cheap. They still work. So, while our crafts table is not empty, do for, let's say, local current craft. We're gonna, I feel like we're using current craft as a global variable somewhere, and this is why you shouldn't use global variables. We're actually gonna call this current craft execution, because we're not using that name anywhere else in the code. And local means it's local to this function, so you can't call it outside unless you passed it to that function. We're going to give this the last item in the table, so crafts table at the last position, which is crafts table. And now we have our final craft item here, which is great. Really great. So what do we need to do? Calculate what we need and how many. Build the item table. Okay. We know that this crafts table, let's actually come back up. I copied it out, but I don't know if we still have it. Here's our crafts table here. We have a total crafts number, which is great. This song is like great. It reminds me of Doom. We want to do local total craft operations gets current craft execution dot total crafts. This number, that number is going to directly correspond with So the very top item in the list, right, for this one would be wired modem. It's going to be a 1 because it's desired amount 1. But and actually, network card's going to be in the list, and it's also going to be a 1 because we can see that there. Machine base will be in the list as a 1, and advanced PCB will be in the list as a 1 as well. That they won't always be 1s. It just happens to be in this situation that they're going to be 1s. So the next thing that we need to do is we need to get the items that we need to craft, and we know we have the module. It's just called module. So we're going to call it like current craft module, basically. Local. See, look, we have a current craft module already like defined somewhere. I hate that we have it already defined somewhere. We have craft module somewhere as well. And the problem again, because I've done any global variables, I don't know off the top of my head if that's a global variable somewhere or not, and I don't want to like use the same names as global variables. And the global variables are just accessible everywhere. So we want to make sure we're never touching the wrong object. So we're going to call this I think we can call it craft module and get away with that. Yeah, we can get away with that. That's going to be the current craft execution dot module. And for example, we come back to here and we take a look. The last item in the list, honestly, because we've added them as we've gone down the list, the last one should be this advanced PCB. So we can look at advanced PCB, our other code, and we can see what functions we have to call in here. And actually, this is one of the newer ones I've done, so it's cleaned up. It doesn't have the output chest anymore. It doesn't have commented out stuff in it. So it's a nicer looking piece of code. We need to look at output per craft. We need required materials. So we know that we only need to craft 1. However, we have to do let's say we wanted to craft 4, right? This still would only mean 1 craft operation, not 4. We have this logic written elsewhere in the code. I know I do. Which means I should probably create a sub-function somewhere and have the old portion of the code call that function, and then have this new portion of the code call that same function, so we don't have duplicate code in our file. But I gotta tell you, I see what time it is now. We've been going for almost 3 hours, and I'm getting a bit tired, so this might actually be our stopping point. If it is our stopping point, bomber. Do you want to send me on Discord, I guess, your thoughts of the stream, or do you want to say it here? We can do either. It's fine for me. I will say, right, for anyone who may be watching this on YouTube or anything, if you've made it to the end, congratulations. That's probably a feat, because we've really just talked about a lot of random stuff. It's been a talking heavy episode, if anything. Feel like we didn't do much. I agree. We didn't really do much. I had a really good time, because actually, like, I'm passionate sort of about coding and whatnot, so like it was fun to like talk about it and explain my thought processes. Had I actually just sat here for 3 hours and coded instead of like streamed it, I would have gotten further. Yeah. This stream was slightly I wanted to do this, and I wanted to test it out as well. See if it was actually even worthwhile thing to do. It actually got me thinking that if we took on a bigger project, and I don't mean a coding Minecraft project, I'm going to leave it at a bigger project. If we took on a bigger project, I could see this working. I'm going to leave it there. That being said, I don't think we'll do another coding stream like this anytime soon. It might happen again. Again, this was sort of a test. The next stream we do will likely be crosscode again. I'm having a really good time in crosscode. And as you mentioned, Bomber, we also had Dwarf Fortress. We still have that one fort. It's still alive. So we should probably keep going with it. And Valheim. Valheim is on the back burner. I've shut the server down. But it is a game that I absolutely want to hit the end game for, at least for, it's an early access game. I at least want to hit the end. I feel like I've got nothing else to say, so we're going to hit the end screen. Thanks for hanging out with me, Bomber. It made it a good experience.